Welcome to Two Variable Statistics. Today we're going to discuss linear regression lines in correlation, and we're going to identify the pattern represented by the regression line and what the correlation means about that pattern. Let's get started. To begin with, the scatter plot relates two quantitative variables. This means two things that we can count. The graph then creates a relationship that we can use to draw conclusions about the association of the variables. So we can use this to describe the pattern between the variables and make predictions about future events. For our first example here, our chart represents the number of great white sharks, the accidents related to great white sharks, and the fatalities caused by great white sharks. And then we have the years and all the numbers corresponding to those years. This information could be a little overwhelming looking at it and trying to identify a pattern. So what we're going to do is identify two different quantitative variables. In this case, we're going to start with the number of great white sharks and the number of accidents related to great white sharks, and we're going to create a scatter plot and use the scatter plot to see if there's any pattern or trend that we can conclude from the way the graph looks. We're going to let the number of great white sharks be our x value and the number of accidents caused by great white sharks be our y value to create our ordered pairs. So for your first ordered pair, we'd have 92,756, 376, and so on. Let's take a look at the scatter plot. So while the numbers might have indicated to this pattern, the scatter plot shows that there's a clear association between the number of great white sharks and the accidents caused by great white sharks. We can see there's an upward trend. And so what that means is, as the number of great white sharks increase, the number of accidents also increase. And that is the pattern that we can associate with this based off of our scatter plot. So here we're going to compare the number of great white sharks with the number of fatalities for our second example. We can see again that there's a pretty clear positive trend, which means as the number of great white sharks increase, the number of fatalities is also going to increase. When you compare this back to the previous example though, we can see that the chart is not as linear as the one with the great white sharks and the accidents. So while we are pretty sure that there is a positive trend, if you had to compare this back to the other example, we're not as confident in our trend. And that's something we'll talk about later with our correlation values. So generally we're going to have one of two associations. Either we're going to have a positive association or a negative association. When you have a positive association and you want to explain the trend, you would say as x increases, y is also going to increase. And you would just substitute in for x and y what the variables actually are. In our previous example, x was the number of great white sharks and y was either the accidents caused by great white sharks or the fatalities caused. If we have a negative association and you want to explain that, you would then say as x increases, y would decrease. And again, you would plug in for x and y what the actual variables are. So we're going to go ahead and practice explaining our trend here, looking at the pattern. Now we can see that our x variable is car weight and the y variable is miles per gallon. Now we can see then if we were to draw a line that it's decreasing, which means we have a negative association. We would then say, as the car weight increases, the miles per gallon are going to decrease, and that's our trend, or association. For our next example, we have the age of a participant and the reaction time in seconds for that participant. Looking at the line that's already been drawn, it is increasing, meaning that we have a positive association. So then our statement to explain the trend would then be, as the age increases for the participant, their reaction time is also going to increase, which means that they're going to have a slower reaction time. Once we have all of our scatter plots, we now need a way to relate them to each other or a way to compare them. So we have correlation. Correlation is represented by the variable r. Our correlation values range between -1 and +1. A correlation value of +1 or -1 is a perfect relationship, which means it is a perfect positive line or a perfect negative line. An r value of 0 means that it has no relationship. So we're going to use these values to help us determine how linear our correlations are, or our scatter plots are. The closer to 1 or -1, the more linear the graph is. The closer to 0, the more random the graph is. And we can then decide which graph is a better representation of data, or which regression line is a better representation of data based off of its correlation value. For our positive correlations, we see the progression here for our different r values. If we start with the r value of +1, you can see we have a perfect positive line. As our r value gets closer to 0, we have a 0.8 here, we can see the points start to become more dispersed and less linear. For 0.5, again, they're more dispersed. We can still see there's a positive trend. The points are increasing, but they're definitely more spread out. If we were to draw a line in between our points, we can see that they're getting farther and farther away from that line. If we do it for our last set of data, with an R value of 0.2, we can see they're even farther away from the line. So the farther away the points are from a straight line, the lower the correlation value is going to be, and the weaker our confidence is that the regression line predicts the pattern. We have the same pattern here for our negative correlations. Again, R value of -1 gives us a perfect negative line, which means that the points are decreasing. And R value of -0.8, again, we can see the points are starting to disperse. And R value of -0.5, again, they're getting even more spread out. And then finally for -0.2, they are almost random. And again, our correlation value tells us how confident we are that our regression line predicts the pattern for these points. And we're going to talk about this more in the next section. But for today, we want to make sure we can explain a correlation and explain a pattern for a scatter plot. That completes our notes for this section. Tomorrow in class, we'll be applying the concept of correlation and also explaining a scatter plot.